Oh, did I lost connection? Yeah, I don't know what happened to the internet, but I feel sorry if you disconnect with me. I think, I don't know. Right. So do you have any other questions? I think our university Wi-Fi is really poor. So that's why I got disconnected, I guess. But anyway, I'll refresh the page and see how are things going. Right, again, yeah, feel free to ask any questions. So Clara, I hope I answered your question, and I don't know if it is recorded, but if it is not, just let me know, okay? Yeah, now you can start posting any questions now. So for the question 14E, I think the sample size should be 1225 to keep the standard error equals 0.2. Okay, any other questions? Oh yeah. Come on guys, please ask questions. Oh, it seems like you guys been so well prepared so that you don't need any help from quiz 2, right? Okay, thank you for your question, Norrisy. When should we check a table and when should we use Excel if both are possible to use? Oh yeah, it's pretty right to ask here. Well, I mean, I think no matter if you use table or Excel, they will give you very similar results. And for the markers, they accept all similar results. So don't worry whether you use table or use Excel. Okay, don't worry. And yeah, we accept both in the markings if there are discrepancies, but I don't think the discrepancy will be very big. Okay, yeah, thank you for your question. Any other questions? Yeah, at the same time, I'm also answering questions from ED. Simply. Any other questions? Yeah, please post questions here, okay? Clara, are you still there? Oh, hi, Clara. Oh, it says 14A was not recorded. Oh, I feel sorry about that. Well, yeah, let's look at question 14E. Oh, that's too bad. So question 14E is about, it's talking about the sampling distribution of sample mean. So maybe your question is about, is asking how to find Z, but actually in question E, 14E. For question 14E, the information given was that you got an exponential population, right? You got an exponential population, and the population mean is 7 hours, and also you got a population standard deviation to be 7 hours, right? Because that is the exponential distribution. All of them equal to 1 on lambda and 1 on lambda, right? Yeah. So given that to be the population distribution, now you want to have this. You want to limit the sampling error or standard error. So sampling error here refer to standard error to be 0.2. Okay, then you just need to determine the sample size here. Again, you just plug in 7 on here. 7 divided by square root of n equals 0.2. And now you need to do the calculation and find n. So you can see n equal to 7 divided by 0.2 square. So 5 is 35. 35 square is 1225, right? Yeah. Okay. So this is how we solve the exponential. How we solve 14A. So again, it's asking to limit the sampling error, which is, I guess, the standard error. Okay. All right, Clara, hopefully I'm answering your question. Now let's look at the question from Alexander Stave. In the quiz, what amount of working do we need to write down if we use Excel and plugging in the values in order to get maximum marks? That's a pretty good question, and I think your coordinator have maybe they have emphasized this for once. He may have said that you need to show all the formulas. Okay, so you don't need to show Excel workings. All right, because that is pretty much like using a calculator. So you don't need to show how you use the calculator to get the results. So you don't need to show your Excel workings. But what you do need to show is the real calculation formula. Okay, so for example, in a t-test, right? So you need to calculate the t-stat. So you need to first put x bar minus mu divided by whatever s divided by square root of n, and then you plug in the numbers 10 minus 3 divided by whatever, right? So that is the calculation you need to perform, and the process you need to write down in the question. Okay, so but you don't need to type in, like in Excel you input 10 minus 3 and then divided by, you don't need to do that. Or when you find critical value, the critical value, for example, if you want to find the critical value, you don't really need to put Excel format. You can directly say from the table or from Excel, I got critical value to be 2.04, 2.02 or whatever, so that we reject the null hypothesis or do not reject the null hypothesis. Okay, so you don't need to show your Excel workings. It's pretty much like you don't need to show, for example, if you are going to use a calculator, you're going to need to write down press 1 and then press plus and then press 3, right, to calculate 1 plus 3, right? So you don't need to do that. Okay, Nora C is asking, do we need to write down sample mean equal what? Standard deviation, etc., etc.? That's also a very good question. So it's all about what kind of letters are you going to use in the question. For example, if the sample mean, you know from the question, the sample mean is 100, okay? So it told you somewhere sample mean is 100. And you want to use that to plug in, to calculate, for example, t-stat, right? And then you do need to specify x bar equal 100 because this is a new thing. And you define x bar to be 100 to equal to the sample mean value, all right? So that's what you need to write down. So for all letters that are new without any values, you need to give them a value and define that letter, okay? Or you can simply write down t-stat equal all of this. For example, t-stat. I mean, there's no one way of presenting your answer as long as it is clear, right? So t-stat is, for example, x bar minus mu divided by s divided by square root of n. And you can say where x bar, okay, from the question you read it, x bar is 100, and mu from the null hypothesis, well, mu, you also have that in the null hypothesis, right? Like mu equal 3, alternative is mu less than 3 or whatever, right? So mu, you already have that value. And also s is whatever from the question, right? 10, and s sample size is 50, so that, yeah. In that way, I think you should be able to get full mark because you not only show the formula, but also you show that you understand those values and how are they related to the information from the question. And then finally, you can just calculate the t-stat and then plug in the numbers 100 minus 3, minus 3, yeah, divided by s, 10 divided by square root of 50, and get a result, okay? Yeah, so, yeah. That's pretty much how you should present your answer. I mean, for Nora's question, it doesn't matter where you put it, right? I mean, when you need to use it, you just write it down, right? Otherwise, for example, if you directly write down like 100 minus 3, so you don't have the formula, 100 minus 3, 10 divided by square root of 50, who knows how did you get those numbers from, right? So, well, again, all your presentations on the exam paper, the purpose should be to make the markers understand, all right? Okay. Yeah, any other questions? Feel free to post any questions here. We still have half an hour to go. Yeah, so please relax and find your questions. Hey guys, do you have any other questions? All right. Oh, you guys really make my life easier. I still remember previously when I did this online consultation for postgraduate units, the watchers are like 100 something watchings. They keep posting questions and the 1 hour consultation finally becomes a 2 hours. Oh my god, that was a nightmare. Anyway, it means you guys are working really hard, so you don't have much questions, right? That's pretty good, especially if you're from my class and you work really hard. You will definitely perform very well in the quizzes. But again, welcome any questions. If not, tomorrow I'm gonna have another 1 hour physical consultation. You are not prepared enough to ask questions. Come on, our exam is on Saturday, all right? So do you think you're only prepared by the time the exam starts? Then you have no chance to do the consultation, right? Or you think we should do it on Friday night? or Friday midnight, right? 0 o'clock or 12 a.m. on Saturday. Yeah, that would be helpful, right? Come on, guys. If you don't have any other questions, why are you still watching it? We still have 7 watchings, don't we? Okay. Finally, we've got the questions from Alexander and Clara. Okay, thank you very much for saving my time. Okay. What the hell? Oh gosh, you start posting questions then. Okay, let's look at the question from Alexander Steve. Could you please demonstrate question 13 from the sample quiz? Still stuck on the concept. Okay, let's see what is in question 13. Where is that? Question 13. All right, let's look at it. All right, yeah. Let's look at question 13 together. So question is here. Question 13 is talking about a survey of Australian workers revealed that 607 out of 1,005 respondents would rather receive an extra 5% of annual pay and only take 10 days of annual leave rather than the current 20 days allowed. So is there evidence that more than 50% of Australians would reduce their annual leave allowance in favor of extra 5% pay? Okay, for question 13, when you say something like, is there evidence alpha equal whatever, this will be about this will be a hypothesis testing question. So now, let's see how we can solve this problem. All right, so let me put my mobile phone back. Oh gosh, it's so hard. Okay, it's back now. Right, let's look at this question together. It says a survey of Australian workers revealed that 607 out of 1,005. So this question will be categorized as the HT, hypothesis testing. Hypothesis test for the proportion, because we look at the proportion of respondents who would like to receive 5% extra annual pay instead of taking 20 days of annual leave, right? So it's about hypothesis testing on the population proportions. So here, let's first quickly go back to the formulas. So for hypothesis test for proportion, we always use z-stat, right? And the z-stat will be calculated by p minus pi divided by pi times 1 minus pi divided by the n, the sample size. And that bad boy follows the normal distribution. To answer this question, you need to first calculate, you can see the number of success, x equal to 0.67, right? And also we have 1,005 respondents. So the sample size will be 1,005. And again, we can then calculate the sample proportion to be 607 divided by 1,005. Whatever the number is, I don't know, but it looks like a very disgusting number maybe. Anyway, this is the sample proportion. So once you get a sample proportion, you can start testing on the hypothesis. So you need to specify the null hypothesis to be the population proportion. So pi is for the population proportion. The population proportion equal, let's say, it says evidence that more than 50%. So the pi equals 0.5. And alternative hypothesis will be pi greater than 0.5, because we are going to test whether we have enough evidence that pi is greater than 0.5, right? Okay, once we set up the hypothesis, now it's time for us to perform the hypothesis testing. But before that, you need to be aware that in order to use that formula, we need to test on the assumptions as well. So what are the assumptions or required conditions for using this formula? Again, from the central limit theorem, we need to require that the n pi greater than 5 and n times 1 minus pi greater than 5, right? So in here, let's see, the n pi is equal to 1005 times 0.5. It's 502.5. It's obviously greater than 5, right? And n times 1 minus pi is again 502.5, which also greater than 5, right? So once those conditions are met, then we are able to use that formula, right? So you can say under null hypothesis, the z-stat becomes p, which is, well, let's do it 607 divided by 1005 minus 0.5, and then divided by square root of 0.5 times 1 minus 0.5, and then divided by n, sample size 1005. So we need to find out this value first. Let me do it quickly on Excel, and you can do it together with me, okay? So please open up your one Excel and do the calculation, all right? Where is it? Yeah. So this z-stat is, oh my god, so hard. 607 divided by 1005 minus 0.5. Oh gosh. Divided by, sorry, I'll need to put a bracket, divided by 0.5 times 0.5 divided by 1005. And I need to put a square root on it. Holy crap. SQRT. All right. Yep. I think that's fair. All right, so finally, I've got the z-stat observed to be 6.5927, right? So this is the z-stat. Now, in order to make our own decision, we need to determine whether this z-stat is in the rejection region or not in the rejection region. So from the alternative hypothesis, we know this is a one-tail test on the right hand side, right? Or the upper tail test. So our z-stat is observed to be 6.5927, and we're going to determine if this value is too far away from 0 to the right hand side. So we need to find the critical value over here. So we need to highlight this area, make it to be 0.5, okay? So the probability here is 0.5, and find this value. Again, you can find it using the statistical table, z-table, or you can use norm.s.inverse, right? Norm.s.inverse INV with probability input 0.95, because on the right hand side, if the probability is 0.5, then the left hand side probability will be 0.95, and this function always have a left hand side probability as an input, right? And cumulative. Oh, no, it doesn't matter cumulative or not, sorry. Inverse 0.95. So it should be 1.645, right? Yeah, I think the result is 1.645. So you should also state here the z 0.05 is 1.645. As z stat is greater than z 0.05, then we can conclude that the null hypothesis is rejected, right? Because it's obviously in the rejection region. It's rejected at 5% level of significance, right? It's rejected at 5% level of significance, so that there is evidence that the proportion of workers who support to increase 5% extra, whatever, exceeds 50%, right? Yeah, you just answer what you are asked, right? There is evidence that blah, 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 blah. All right, so this is how you should solve this kind of question, okay? Yep. All right. So Alexander, hopefully I answered your question, okay? This is question 13. This is question 13 from your sampled questions, all right? Yeah. Okay, now let's look at the question from Clara. Clara says 18a, why is it both Poisson and exponential distribution? All right, that is a pretty nice question. Question 18a. Let's see. Where is question 18a? Yeah, it says traffic accidents occur at an average of 5 per week at a certain intersection. Oh, so many, right? 5 per week, okay? 5 per week at a certain intersection. So A says, what distribution does time between accidents follow? All right, so for time between accidents, it follows exponential distribution, right? Because 5 per week, for exponential random variable, okay? Exponential random variable, it's always about the waiting time, right? Or the time between two occurrences. But for the Poisson, it is the number of occurrences in a certain time interval. So what we have is that if the number of occurrence follows Poisson distribution, then the time between each occurrence, okay, or between two occurrences follows exponential distribution. All right, so that's the relationship between Poisson and exponential distribution. Again, justify your answers and give details, including mean and variance of the distribution, and then draw the density function of this distribution in Excel or StatCrunch. Once again, when we talk about exponential or Poisson distribution, you should be aware that when we talk about any distribution, it's about random variables, right? So for exponential distribution, it describes the distribution of a continuous random variable. So that's why it usually applies to the time, because time is continuous. So that's why we usually denote time x equal to the time between two occurrences and say x follows an exponential distribution, right? And this is something that most of you lose mark in quiz 1 already, because you need to understand what is the random variable in the question. Now, the question asks you, what distribution does time between accidents follow? So time is never Poisson distribution, okay? Only the number of occurrence follows Poisson distribution. All right, so hopefully I answered your concern, okay? So it's all about what you are asked. If it is asking what is the distribution of time between the two outcomes, then that follows exponential distribution. Number of occurrence in 1 week follows Poisson distribution, because the number of occurrence can be 1, 2, 3, 4, but the time can be 1.2 days, 1.21 days, 0.3 days, or even 0.2 weeks, so on and so on. All right? Okay, so that's the differences between exponential and Poisson distribution and relationship between them. Okay? All right. Now, hopefully I answered your questions, Clara. Nora C is asking, can Tony explain question 8 again? Did I explain question 8 before? I don't know, but yeah, maybe not again. First time, right, explaining question 8. Well, let's see question 8. Oh, I just have a quick look through the question 8. and I found it's pretty much ask you about the combination, the linear combination of the expected value and the variance of two random variables. Okay, so let's see, x have a mean of 10 and the variance, y have a mean of 16. Variance of x is 9 and variance of y is 25. And the covariance between x and y equal to -4. So you're asked to find the expected value and variance of 2x minus 7 or so on and then so on. Okay, so the basic rule that we have to follow is that the expected value of any linear combination ax plus by equals ax plus bey, right? So that's the basic rule. And also the variance of ax plus by is calculated to be a squared variance of x plus b squared variance of y plus 2ab covariance between x and y. So this is what you learn from your formula sheet. One more thing we got to learn is that the cx plus d, it's simply cex plus d. And the variance of cx plus d, it's simply c squared variance of x. And ignorance of this, ignore the d, because by plussing d, it doesn't affect the fluctuation or volatility of your data, right? So those are the basic rules that you need to apply in order to solve this problem. So let's do a quick example. A, find the expected value and variance of 2x and 7. So 2x minus 7. Expected value will be 2 times ex minus 7. So it's 2 times 10 minus 7, 20 minus 7 is 13. A variance of 2x minus 7 equal to 2 square variance of x. So equal to 4 times variance of x is not 436, right? So it's 36. All right, so that's how you solve the problem, okay? So let's do question B. Expected value of 3x minus 4y. 3x minus 4y, again, equal 3ex minus 4ey. So it's 3x 30 minus 64, which is minus 34, right? This is question B. And question C, find the expected value of 4 minus 3x and 4 minus 3x, 4 variance of it. Okay, good. So E4 minus 3x equal to 4 minus 3 times ex, right? It's equal 4 minus 3 times 10, which is minus 26. And variance of 4 minus 3x equals, so ignore this 4. So minus 3 squared, so it's going to be 3 squared, or minus 3 squared, multiply variance of x. So it's 9 times variance of x is 9981. Okay, finally, D. Oh my god, D, I think D is the most difficult one. So for question D, we asked to find the expected value of 4 minus 3x plus 2y. So again, this one is easy. 4 minus 3 times ex plus 2 times ey. It's going to be 32 minus 30 plus 32 plus 2, 6, right? But the variance of 4 minus 3x plus 2y, again, it's basically just equal to, so for the 4, doesn't matter, right? It will not affect the variance. So here, it's 3 square variance of x plus 2 square variance of y and plus 2 times 3 times 2, but in here it should be minus 3, right? So it's 2 times minus 3 times 2 times covariance between x and y. So if you plug in the numbers in it, it's 9 times 9 plus 4 times 25 minus 2, 3, 6, 12 times covariance minus 4. So minus 4. Again, it becomes positive. So this is 81 plus 100 minus also plus 48. So it's going to be 229, right? So that will be the variance and the expected value of 4 minus 3x plus 2y. So once again, the question will not be that hard once you know what formulas should be used, right? So that's why every time you have a question, you should first ask yourself WTF, right? Which means what's the formula, right? What's the formula? So once you know those formula, then you got to know how to solve the problem. Okay, any other question? Oh my God, I haven't seen the live chat and oh my gosh, so many questions. Clara is asking, later in exam, if our formula contains cell number or use an array of data such as equal, do we just write cell numbers? Hey, as I said, Clara, we don't require you to write down any Excel functions on the exam paper, okay? You don't need to write anything on the exam paper, okay? All right, now let's look at the question from Jack Green. Jack Green is saying, hi Tony, could you please explain question 1 and 2, how to solve them, and the difference between them in determining how to use z-values or t-values. Do you use only z-values when you are told the values of the entire population, t-value taught a set of values or that are assuming? Okay, yeah, I know your concern. Yeah. I haven't seen question 1 and 2 yet, but I guess your concern is pretty much like when do we use z distribution, when do we use t-distribution in constructing either confidence intervals and hypothesis testings. So now I'd like to share with you a secret table, right? So with this table, you are going to know everything that you are required to solve those problems, either confidence interval and hypothesis testing, okay? So CI and HT summary. So again, if you know all the contents, you can just say it together with me, right? If not, you can just copy it down. All right, let's do this together. Okay. So first of all, for confidence interval and hypothesis testing, the first thing that we're going to be dealing with is the means. So when we want to estimate population means, right? So when we are going to estimate population means, we need to know different things. So to estimate population mean, what is the point estimator, right? Like what is the point estimator of the population mean? Again, obviously, it's always X bar, right? Okay, so that is one thing you need to know. We use X bar to estimate mu. Now, for this point estimator, it must have its own distribution. So you also need to know the mean and variance of X bar. So the mean of X bar and the variance of X bar is actually mu, right? The mean of X bar is always mu. And the variance of X bar is sigma squared divided by n. Is that right? Okay, so the mean and variance of this point estimator is another thing that you need to know, okay? Therefore, in constructing the sampling distributions, we just need to use those information to construct our confidence interval or hypothesis testing. So let's have a quick look at it. Before that, according to the central limit theorem, right, you need to know the assumptions to assist your calculations. So first of all, assumption. How do we make X bar to follow a normal distribution? So either the sample size is greater than 30, right? So then that will be the sampling distribution of X bar will always follow normal distribution, right? Or even though n is not greater than 30 but it's greater or equal 15, we need to assume what? We need to assume a symmetric population in order to have a normal X bar, right? And thirdly, even when n is less than 15, we not only need to assume a symmetric, but we need to assume a normal population, right? So for n greater than 30, any population, right? 15 assume symmetric population. Less than 15, we need to assume normal population, okay? So maybe in the question, if you are asked about the assumptions, you need to look at the sample size and determine what kind of assumptions you need to make on the population, okay? So those are the underlying assumptions and the underlying distributions, okay? So X bar follows normal distribution with mean mu and sigma square divided by n. So the first scenario is when population variance is known. When the population variance is known, the confidence interval becomes X bar plus or minus z half of alpha times sigma divided by square root of n. So this is pretty much the point estimator plus or minus critical value times the standard error, right? Standard error comes from the variance, right? And the hypothesis testing. In the hypothesis testing, our test statistic, z-stat, we're going to use a z-stat because here is z, right? The z-stat is simply the standardized version, X bar minus mu. Mu is from null hypothesis divided by sigma divided by square root of n. So this is when sigma is unknown. We use this, but again, the assumptions are here. However, when sigma square is known, right? When sigma square is known, unknown, yeah. When sigma square is unknown, we no longer know the sigma value, right? So instead of use z distribution, we use t distribution, okay? So confidence interval will be X bar plus or minus t half of alpha with degree freedom and -1 times, instead of using sigma, we use s divided by square root of n. And again, for hypothesis testing, we have a t-stat instead of z-stat to be X bar minus mu divided by, instead of sigma, we use s divided by square root of n. Okay, so those are the two different scenarios when we deal with the estimation of mu. Okay, estimation of mu. And one last thing, when we talk about the estimation of proportion, right? About pi. So we need to know the point estimator becomes P, right? And we know P follows a normal distribution with a mean equal to pi and a variance equal pi times 1 minus pi divided by n. Only if when n pi is greater than 5, greater or equal to 5, and n times 1 minus pi greater or equal to 5, right? So this is the sampling distribution from week 6. Well, I can tell you, this part comes from week 6, okay? Same thing, this part from week 6. And all the confidence intervals comes from week 7. And hypothesis testings comes from week 9, I guess. No, week 6 or week 7? Wow, I can't remember. Is it a week 7? Sorry. Week 6, 7, 9. 6 is about continuous distribution, right? Sorry. Yeah, this is from week 7. So all of those comes from week 7. And this is from week 8. And this is from week 9. Week 8, week 9. 7, 8, 9. So we build everything in week 8 or 9 based on week 7's sampling distribution knowledge, right? So if you forget about anything of this, go back to week 7 slides. And again, for the proportion, if you forget any of this, go back to the week 7 slides. So for here, we don't have sigma normal unknown. We only care about confidence interval. Confidence interval will be built by P plus or minus Z half of alpha multiplied by the standard error. The standard error will be pi times 1 minus pi divided by n, but as we don't know the pi value, we use P here. P times 1 minus P divided by n, because pi is the population proportion, right? Now, for hypothesis testing, it's a little bit different because we constructed z-stat, but we know pi value in the null hypothesis, right? So in here, that's why we usually plug in P minus pi divided by, so for the standard error part, we use pi times 1 minus pi divided by n. So in here, maybe it's very easy to make mistake when you calculate hypothesis testing for the proportion. Many students tend to use P instead of pi in here, and that will be wrong. So you can see the previous question as an example. Where do we at? Yeah, the question 13, right? When you look at question 13, you can see I use pi, right? Pi in the null hypothesis to plug in the standard error, but not the P, okay? So that's for hypothesis testing. But for confidence interval, you need to use P. Okay, hopefully this chart gives you a summary of what you need to know from week 7, 8, and 9. Look at that. One page includes all week 7, 8, and 9. Oh, wow, that is beautiful, isn't it? All right, now let's come back and see any other questions. Jack Green, okay. Yeah, so Jack Green, hopefully I answered your question, right? So when sigma is known, we always use Z. When sigma is unknown, we always use T. And for proportion, we always use Z, okay? Hopefully I answered your question. Now, let's look at the question from, any other questions? Okay, guys, any other questions? Please post any questions if you have any. Maybe I need to refresh this page because the internet goes down. Yeah. Okay, do you have any other questions? Oh, it's already 8 p.m. If in 2 minutes time you don't have any other questions, I will turn off this live streaming device, okay? So I'll wait for another 2 minutes, okay? 2 minutes. Yes, question 20D. What is question 20D? I don't know. Question 20D. You plan to invest? Yeah, obviously you will be given. Yes, you will be given. Yes. Yeah. Any other questions? well, question 20D, we've used exactly the same formula as question 8, right? Yeah. Where's question 8? Where did I put my question 8? Oh yeah, question 8 is here, right? Yeah. Exactly the same formula, right? This is when you construct a portfolio, right? You use these formulas to calculate your portfolio expected return and portfolio risk, right? Or variance or standard deviation. Yeah. Okay. 1 minute to go. Any other questions, guys? Okay. It seems like none of you have any question. So if you still have questions, you can come to my consultation on tomorrow, 1:30 to 2:30. But again, you need to make sure you come really early because I'm pretty sure tomorrow we will take the full hour up. Okay. And the location is outside ABS pod or ABS 4036 outside. Yeah, I'll be wait on the couch or in the dining area. I will be somewhere on level 4. Okay, you will find me. And also, if you want to do a last minute, survival, you can also go to my 11 a.m. tutorial on Friday. So it's 11 a.m. to 1 p.m. in the Sydney Nanoscience Hub. So it's SNH 4003 or 405. I can't remember. It's 405, right? Sydney Nanoscience Hub 405. Anyway, I'll see you guys, some of you guys tomorrow. Anyway. But if you do want to come and see me, and after that you can also ask questions, let's do that. Okay. Yeah. Okay. Right. That's all for today's consultation. Thank you very much for attending this consultation. Again, only 7 guys is watching. I don't know why this small number. Okay. I'll see you tomorrow and wish you the best luck in your final exam, in your quiz too. All right. Okay. See you guys. Have a good night.